from organic section, Introduction to Polymer Chemistry. This chapter is very simple and you can score out of out. So let us start with the main and the very important term of this chapter, that is polymer. What is polymer? This word, if you break in two parts as poly and mer, this polymer word originates from Greek word. Poly means many. Poly means many. Large number, many, and mer means unit or part. Poly means many and mer means unit or part. When many units come together, many units come together, they form a big unit. Many units, these are small units. These are small units. These are small molecules and they form a large molecule. Many small molecules, many small units, they combine chemically and they form a large molecule. These many small units are known as monomers. Monomers. Mono indicates one and mers means unit. One unit. Such monomers, if they are many, we write as n number of molecules. These n number of monomers are joined together. They are joined together chemically and they form a large molecule known as polymer. And thus, many units of monomers come together, they are joined chemically. And thus, when n number of many large number of monomer units are linked together chemically, then a bigger molecule, larger molecule is formed, which is known as polymer. What are polymers? These are complex molecules. Polymers are complex molecules. They are large, they are giant molecules. They are complex, giant molecules. As the molecule of polymer is giant, it possesses high molecular mass. Polymers, these are the molecules with high molecular mass. And they are composed of many repeating small monomer units. They are composed of repeating units All these points for polymers are very important and you have to remember these points one by one. So what are polymers? In the definition of polymers, you have to write all these important words. So polymer, it is a word, it originates from Greek word, and in Greek poly means many and mer means unit. These many units of monomers are chemically joined to form a big unit called polymer, and these polymers are complex in nature. They are giant molecules, they possess high molecular mass, high molecular weight, and they are composed of repeating units called monomers. Next term which is related to polymer is polymerization. Polymerization. What is polymerization? It is a process. It is a process in which monomers are converted into polymers. Polymerization is a process in which n number of monomers are converted into polymers. This conversion of monomers into polymer by a chemical process known as polymerization, and thus we can get polymer by connecting, by combining units, large number, many units of monomers. When monomers are connected to form a big molecule, this process is known as polymerization. Monomers, the n number of molecules are given on the left side of this word monomer, and how to identify polymer? This n number is given on the right side of this molecule. So polymer, see the indication of this n. If n is before the molecules, it indicates these are the monomers. And if n is given after the molecule, which indicates it is a molecule of polymer. So in this chapter for 2021, for this year 2021, some portion from this chapter is reduced, and the reduced chapter is 15.2 from this chapter 15.2, and that is the part of classification of polymers. This classification is not included in the board exam 21. So remember this important point. So we are moving to the next point about the synthetic polymers, synthetic fibers. There are three important synthetic fibers, and we will study these three fibers one by one. So let us start with these fibers. Synthetic polymers, synthetic fibers, synthetic fibers or synthetic polymers. The fibers we are going to study are synthetic, means they are purely obtained from chemical substances. They are man-made fibers, and thus they are synthetic. Man-made, which are obtained from purely using chemical substances. Synthetic fibers. So first we'll consider nylon 6. First synthetic fiber, nylon 6. This fiber nylon 6 is a homopolymer. It is a homopolymer. Why this fiber is homopolymer? Homo indicates same units of monomers. Only one type of monomer is used for the preparation of this fiber. Only one type of monomer. Only one type of monomer. Here monomer units are of same type, and hence this fiber is an example of homopolymer. This is polyamide fiber. It is polyamide fiber. Why this is polyamide fiber? Poly indicates many and amide indicates amide linkage, and the amide linkage is CONH. We can write this linkage in the double bond or separate form as C double bond ONH. Such type of amide linkage is present in this fiber, and thus the name polyamide fiber. This linkage is repeated in the fiber, in the polymer, and thus it is polyamide fiber. It is homopolymer, it is polyamide fiber. And a very important point about this fiber, what are the monomers of this fiber? Monomers, the repeating units which are required to prepare this fiber are epsilon caprolactam molecules. Epsilon caprolactam. Epsilon caprolactam is the raw material which is used for the preparation of this fiber. Epsilon caprolactam. You have to remember the name of this raw material of this fiber. Raw material epsilon caprolactam. Monomers of epsilon caprolactam are used. Why the raw material is known as lactam? What is meant by lactam? This epsilon caprolactam is prepared from omega amino caproic acid. Omega amino caproic acid. Omega amino caproic acid. As it is acid, it contains carboxyl functional group. It is omega amino caproic acid. This is alpha carbon, beta, gamma, delta, omega. Alpha, beta, gamma, delta, omega. And on this omega carbon, amino group is present, and this is omega amino caproic acid. This molecule contains two different functional groups. One is carboxyl functional group and another is amino functional group. These two functional groups react. This is called intramolecular reaction. Intramolecular reaction. They react intramolecularly. Intramolecularly means carboxyl and amino of the same molecule reacts together and they form cyclohexane. Therefore, after reacting, when they react intramolecularly, they form a cyclic ring, and this cyclic ring contains CO and NH group, and in between these CO and NH, 5 methylene groups are present. These 5 methylene, 1, 2, 3, 4, 5. Thus, when amino and carboxyl group react intramolecularly, a cyclic ring is formed, and this is known as lactam. This lactam is obtained from caproic acid, omega amino caproic acid, and thus the name caprolactam. Raw material of nylon 6 is caprolactam, as it is obtained from caproic acid, omega amino caproic acid. These two functional groups react with each other. This reaction takes place intramolecularly, and thus the lactam is formed. And this lactam is obtained from omega caproic acid, and the name caprolactam. So remember, the raw material which is used for the preparation of nylon 6 is epsilon caprolactam. Using this epsilon caprolactam, we are going to prepare nylon 6. Then how this preparation takes place? See, we will take monomers of epsilon caprolactam. This is CO, this is NH, this linkage is very important, and in between this carbonyl and NH, there are 5 methylene groups. Methylene group is CH2. Remember, methane CH4, methyl CH3, and methylene CH2. In this epsilon caprolactam, there are 5 methylene groups. CH2, CH2, or this is 4th, this is 5th, which is attached to the nitrogen. Thus, 5 methylene groups with CONH, it is epsilon caprolactam. This epsilon caprolactam is heated with water at high temperature. This temperature is maintained nearly at 533 Kelvin. This is high temperature. This epsilon caprolactam is heated with water at this high temperature. What happens? Breaking of this cyclic rule takes place, and thus we say the cyclic opening of cycle by the process of polymerization, and thus it is open cycle polymerization. Open cycle polymerization takes place. When epsilon caprolactam is heated at 533 Kelvin, these monomers, so write N before these molecules. Don't forget to write N before the molecule of epsilon caprolactam. Thus, large units, large molecules of epsilon caprolactam on heating with water undergo polymerization. And in polymerization process, breaking of the CO, carbon, and NH, carbon nitrogen bond breaking takes place, and thus a polymer is obtained in which at one end there is carbonyl, CH there is NH group, NH. And thus, when this cyclic structure breaks, carbon and nitrogen separates, and these two groups are at the ends of this chain, and thus there is linking. There is linking at this side, and thus a polymer is obtained in which we write N on the right side of this molecule. Don't forget to write this N on the right of this molecule. And thus the polymer obtained is nylon 6. This is nylon 6 fiber, nylon 6 polymer. Thus monomers, many molecules of epsilon caprolactam on heating with water undergo polymerization to form a polymer, which is a synthetic polymer, synthetic fiber, nylon 6. Why this fiber is known as nylon 6? As the repeating unit of this polymer is epsilon caprolactam, and it contains total 6 carbon atoms. Let us count all the carbon atoms in this raw material. This is first carbon, 1, 2, 3, 4, 5 and 6. As the raw material contains 6 carbon atoms, the name is given as non-6. So, preparation is very simple. You can write this preparation by knowing the details about the structure of epsilon caprolactam. You have to remember the conditions of this reaction. Reaction with water at nearly 533 Kelvin, and write the correct structure of nylon 6. In between carbon and nitrogen there are 5 methylene groups. At one terminal you have to write C double bond O. At another terminal you have to write NH, and in between these two there are 5 methylene groups. So preparation of nylon 6 is very simple, and remember why this is. It is related to the number of carbon atoms which are present in its raw material. This nylon 6 is lustrous fiber. It has luster and it has high tensile strength. Remember these two properties of this fiber. It is a lustrous fiber, it has luster and it has high tensile strength. High tensile strength. Where it is used, this nylon 6 is used. It is used to make fibers. Second, it is used for making brushes. And there are various brushes. The bristles of these bristles of the brushes are obtained from nylon 6 to make fibers and to make bristles of brushes. And thus remember these two properties and remember these two simple uses of nylon 6. It is a homopolymer. It is a polyamide fiber as it contains CONH linkage. CONH linkage is amide linkage. This amide linkage is repeated and thus it is polyamide fiber. Now we will move to the next fiber. Next synthetic fiber, and that is nylon 66. Another synthetic fiber, nylon 66. Second fiber, nylon 66. It is a heteropolymer. It is a heteropolymer, which is also known as copolymer. Copolymer, heteropolymer or copolymer. Why it is known as a heteropolymer? Hetero indicates different. Nylon 66 is prepared by using different molecules of monomers. One type of monomers are not used. Two different types of monomers are used for the preparation of this fiber. As the different monomers are used, different means hetero, and thus this polymer is known as heteropolymer. It is a polyamide fiber. Polyamide fiber. Polyamide fiber. As this fiber contains amide linkage, and this amide linkage is repeated many times, and thus it is a polyamide fiber. This fiber is obtained by condensation. This is an example of condensation polymerization. It is prepared by condensation polymerization. All of you know condensation is joining of two molecules. When joining of two molecules takes place, a product obtained undergo polymerization. First condensation takes place, and the condensation is followed by the process of polymerization. Thus, this is condensation polymerization process. And the very important point about this fiber, why the name 66? As it is heteropolymer, different molecules of monomers are used, two different types of monomers are used, and each of its monomer contains 6 carbon atoms. As different monomers are used, each monomer contains 6 carbon atoms. As two different monomers take part in the reaction, each has 6 carbon, it is known as 66. What is the raw material used for the preparation of nylon 66? That is very important. Raw material of this fiber. Raw material. First and the important raw material which is required for the preparation of nylon 66 is adipic acid. Adipic acid. It is a carboxylic acid, and adipic acid is dicarboxylic acid. As it is dicarboxylic acid, it contains 2 carboxyl functional groups. At the two ends of this molecule, there are 2 carboxyl functional groups, and in between these 2 carboxyl functional groups, there are 4 methylene groups. CH2 4 times. 4 methylene groups. And all of you know, methylene group is CH4. This is adipic acid, dicarboxylic acid. There are 4 methylene groups, adipic acid. And another raw material is hexamethylene diamine. Hexamethylene diamine. Hexamethylene. Hexa indicates 6. Methylene means CH2. There are 6 groups. 6 CH2 groups. Hexamethylene. And at the 2 ends, there is an amino group. At one end, there is NH2 group. And on another end, there is another NH2 group. Thus, this raw material possesses 2 amino groups, and thus it is diamine. And the name of this molecule is hexamethylene diamine. Adipic acid contains total 6 carbon atoms, 4 from methylene and 2 from carboxyl. 1, these 4 carbon, 5, and this is 1 more. Thus, adipic acid contains 6 carbon atoms. This another raw material, hexamethylene diamine, contains 6 carbon atoms. 6 carbon atoms. And thus, each of its raw material contains 6 carbon atoms. And thus, the name 66. 2 times 6. 66. Nylon 66. Then how preparation of nylon 66 takes place? So this preparation is in 2 steps. Let us see how this preparation takes place. So in the first step, condensation of 2 monomers of adipic acid and hexamethylene diamine takes place. So first step is condensation. Joining of 2 molecules takes place. Condensation. So first consider monomers of adipic acid. Adipic acid is CH2 4 times, COOH 2 times, COOH. Adipic acid. Monomers of adipic acid, and to write monomer, write N on the left side of this molecule. N number of molecules of adipic acid reacts with N number of molecules of hexamethylene diamine. Hexamethylene diamine. CH2 6 times, NH2, NH2. When equimolar mixture, when these 2 are mixed equally, condensation takes place. How condensation takes place? Nitrogen of hexamethylene diamine has a lone pair of electrons. It abstracts proton of this carboxyl functional group, and thus these 2 molecules are joined through COO. When this nitrogen abstracts this proton, this oxygen becomes negatively charged, and when this proton is abstracted from nitrogen, NH2 changes to NH3. NH3, as pair of electrons is used to abstract proton, positive charge is developed on this nitrogen, and thus in between these 2 molecules, COO minus NH3 plus is formed. On this side, CH2 remains as it is, and this NH2 takes proton to form NH3 plus. On this side, COO minus, this carbon is linked with 4 methylene groups. COO minus, COO minus. As when these two molecules are joined together, these charges are developed and thus nylon salt is formed. In the second step, this nylon salt undergo polymerization. Polymerization takes place when it is heated at high temperature, nearly 553 Kelvin, and reaction takes place under pressure, and elimination of water H2O takes place, and thus two molecules are joined through peptide linkage CONH, and the remaining molecule as it is NH on this side, CH2 4 times, CO, and thus polymer of nylon 66 is formed. Thus condensation is followed by polymerization and the preparation of nylon 66 takes place. In the first step, in the condensation, monomers of adipic acid and hexamethylene diamines are used, and thus this is nylon salt N times. N number of molecules of nylon salt are obtained. These nylon salt monomers undergo polymerization when heated at 553 Kelvin under using pressure. Water elimination from this middle part H2O, and thus the group is CONH, newly formed this CONH group in between these two molecules. Similarly, at this end, removal of two hydrogen atoms from this group takes place, and thus NH. On this side, removal of oxygen takes place and thus CO group, and thus this chain, this unit is repeated n times, and thus we say polymer nylon 66 is obtained. If you arrange these two molecules in a proper way, then you can easily go through these two steps and you will get the polymer of nylon 66. As nylon 66 polymer contains the CONH, amide linkage n times, and thus this is polyamide fiber. This nylon 66 has high tensile strength. This is high tensile strength fiber, and this nylon 66 is used for making ropes or surgical sutures. So this fiber is also important. So try to remember the raw material of nylon 6 and nylon 66. Nylon 6 epsilon caprolactam, nylon 66 adipic acid and hexamethylene diamine. In the tomorrow's lecture, we will continue the remaining part.